Dear students, welcome to the video lecture series. Today in this presentation we will be discussing coupling methods. This presentation is created and narrated by Hemant Satpute, teacher, Department of Electronic Science, Fergusson College, Junior Wing, Pune 4. Note that the material presented in this presentation is taken or is adopted from the textbook Basic Electronics and Linear Circuits written by N. Bhargava, D.C. Kulshreshtha and S.C. Gupta. So, in lecture number 1, we will be learning introduction as how to couple two stages of an amplifier or what is the need. Then first method of coupling, that is resistance capacitance coupling. In this method we will be learning the circuit diagram, its operation, then frequency response, then advantages, disadvantages and applications of this coupling method. Well, now let's begin. In a multi-stage amplifier, the output of one stage makes the input of the next stage. Can we connect the output terminals of one amplifier to the input terminals of the next amplifier directly? This may not always be possible due to practical difficulties. We must use suitable coupling network between two stages so that a minimum loss of voltage occurs when the signal passes through this network to the next stage. Also, the DC voltage at the output of one stage should not be permitted to go to the input of the next. If it does, the biasing conditions of the next stage are disturbed. The coupling network not only couples two stages, it also forms a part of the load impedance of the preceding stage. Thus, the performance of the amplifier will also depend upon the type of coupling network used. The three generally used coupling schemes are resistance capacitance coupling, transformer coupling, and number 3, direct coupling. Let us first discuss the resistance capacitance coupling, that is RC coupled transistor amplifier. Now let me tell you, this is the most widely used method. In this scheme, the signal developed across the collector resistor RC of the first stage is coupled to the base of the second stage through the capacitor CC. So coupling capacitor CC blocks the DC voltage of the first stage from reaching the base of the second stage. So in this way, the DC biasing of the next stage is not interfered with. For this reason, the capacitor CC is also called as a blocking capacitor. Some loss of the signal voltage always occurs due to the drop across coupling capacitor. This loss is more pronounced when frequency of the input signal is low. This is the main drawback of this coupling scheme. However, if we are interested in amplifying AC signals of frequencies greater than about 10 Hz, then this coupling is the best solution. It is the most convenient and least expensive way to build a multi-stage amplifier. RC coupling scheme finds applications in almost all audio small signal amplifiers used in record players, tape recorders, public address systems, radio receivers and television receivers, etc. Now let us see actually when this question is asked, what exactly to write in the exam. So in the exam you have to first draw the circuit diagram. So this is the circuit diagram. This is the most widely used coupling type as it is cheap and provides excellent audio fidelity over a wide range of frequency. This method is usually used for voltage amplification. Now in this method, first stage of RC amplifier is connected to the second stage of RC amplifier through the capacitance and the resistance, means the output resistance of this circuit. So that's why this is called as RC coupling. Here R1, R2, RC, RE, this is the biasing networks or biasing resistors for the first stage. Similarly, R1, R2, RC, RE are the biasing resistors for the second stage. So two identical stages have been used. Cin and Cc. Cin is the input coupling capacitor, Cc is the output coupling capacitor, and this Cc is the intermediate coupling capacitor which couples the output of first stage to the input of the next stage, while Ce is the emitter bypass capacitor. Okay, now let's begin. A coupling capacitor Cc is used to convert the output of first stage to the input, that is the base of the second stage. Output of first stage to the input, that is base of the second stage. As the coupling from one stage to next is done by a coupling capacitor followed by a shunt resistor, such amplifiers are called as RC coupled amplifiers. I hope the name is clear. The resistances R1, R2, RC, Re form the biasing and stabilization network. The emitter bypass capacitor Ce provides low reactance path to the signal. Without it, the voltage gain of each stage may get lost. The coupling capacitor Cc transforms AC signal but blocks DC. This avoids interference between various stages and the shifting of operating point. Now operation. Let's see the operation of this two-stage RC coupled amplifier. So when AC signal is applied to the base of the first transistor, it appears in amplified form across its collector load RC. This output is given as input to the next stage for further amplification through coupling capacitor Cc. Thus, cascaded stages one after the another amplify the signal and overall gain gets increased. The overall gain is equal to the product of the gains of individual stages. Let us see now the frequency response. Now this adjacent figure shows the frequency response of a typical RC coupled amplifier. Frequency response is a graph of voltage gain against the frequency, or to the log of frequency to be precise. It shows the voltage gain drops off at low frequencies less than 50 Hz and at high frequency greater than 20 kHz, whereas it is uniform over mid frequency range from 50 Hz to 20 kHz. Now at lower frequencies less than 50 Hz, the reactance of coupling capacitor Cc is high, given by equation Xc is equal to 1 over 2 pi Fc, where Xc is the reactance of the capacitor. Hence, very small part of signal passes from one stage to the next stage, thus the output is poor. Also, Ce, emitter bypass capacitor, cannot shunt the emitter resistance Re effectively because of its large resistance at low frequencies. Due to these factors, voltage gain falls at low frequencies. So this is the major reason. At high frequencies greater than 20 kHz, the reactance of capacitor Cc is very small and it acts as a short circuit. So this increases loading effect of the next stage and reduces the voltage gain. Also at high frequency, capacitive reactance of base emitter junction is low, which increases the base current by reducing current amplification factor beta. Due to these reasons, the voltage gain drops at high frequency. This is shown over here. Now remember, in exam they specifically asked these questions ki why at low frequencies the gain of the amplifier drops, why at high frequencies gain of the amplifier drops, especially with RC coupled amplifiers. Now at mid frequencies between 50 Hz to 20 kHz, the voltage gain of the amplifier is constant. So the effect of coupling capacitor is such as to maintain a uniform voltage gain. As frequency increases, reactance of Cc decreases, which tends to increase the gain. At the same time, lower reactance means higher loading of the first stage, which reduces voltage gain. So these two factors cancel each other and keeps the voltage gain uniform at this frequency range. So this is why at mid frequencies the voltage gain of the RC coupled amplifier remains constant. Now let us quickly discuss the advantages of RC coupling scheme. Number one, it has excellent frequency response over the audio frequency range. Number two, cost is low as only resistors and capacitors are used, which are very cheap. Number three, the circuit is very compact. So these are the advantages. Now let us quickly learn the disadvantages. Number one, they have low voltage and power gain. Then number 2, they have the tendency to become noisy with age. And number 3, impedance matching is poor. So these are the disadvantages of RC coupling scheme. Let us quickly learn the applications. First application, RC coupled amplifiers, they are widely used as voltage amplifiers. For example, in the initial stages of public address system. And number 2, they are useful in sound section of amplifiers, record players, etc. Well, students, that's all for today's lecture. Stay tuned for the next lecture in the series, and also do not forget to visit the YouTube channel of FYJC Vocational Electronics for all such explanatory videos.